Hello, World Congress of Soil Science attendees. Welcome to my poster. My name is Cole Smith. I'm a PhD student at the University of California, Davis, as well as an employee with the University of California Agriculture and Natural Resources. I'm joined on this project by my colleagues, Maria de la Fuente from UCANR, Shazlu Barker from the University of Wisconsin-Madison, and William Horwath from the University of California, Davis. In this project, we evaluate compost application to soil. Compost can be an important conservation management strategy, but more information is needed on the effect of carbon-rich materials such as compost and their addition to soils and how this affects N2O emissions, specifically N2O derived from fertilizer. Here we evaluate compost application under different soil and moisture conditions, as well as in contrasting soil types with different textures. Oftentimes in the field, it's hard to evaluate climate conditions. So we were able to do this using growth chambers. We grew lettuce, which is a quick growing crop, over 2 months in 2 growth chambers set at 2 different temperatures, 23 degrees C and 28 degrees C. Within these growth chambers, we were able to establish 2 different moisture regimes, soil moisture regimes, at 40% water holding capacity and 60% water holding capacity, as well as the pots that they were growing in were filled with 2 types of soil. These types of soil are the Salinas clay loam and the Metz fine sandy loam. Both of these soils have contrasting textures. For this project, we built specialized chambers to be able to hold the entire pot, including the plant, and measure gas coming off of them over the period of 1 hour. We then took these 4 points measured over 1 hour and were able to derive a flux. From this flux, we calculated the cumulative N2O emissions over the entire growth period. To better understand the fertilizer component of the total N2O pool, we used 15N labeled urea. We applied this urea pre and post planting. We then calculated the fertilizer-derived N2O emissions using the 15N enrichment values. Our results, as you can see, show that compost was found to have a significant influence on the fertilizer-emitted N2O, but this was dependent on temperature. Also, the interaction of temperature and moisture contributed significantly to total fertilizer-derived emissions. This was an expected result. Our lowest fertilizer-derived emissions happened under the scenario of the lowest temperature and the lowest moisture, whereas the highest emissions occurred under the lowest temperature and the highest moisture, somewhat unexpected. Our conclusions highlight that compost can play a very important role in conservation nutrient management, but that the impact of compost, specifically on the loss of fertilizer as N2O, is dependent on the climate conditions, soil moisture, and soil temperature. This needs to be further evaluated, as previous studies have highlighted the role that compost can have in reducing N2O, but have been limited in their ability to contrast these variables. Please reach out if you're interested in learning more about this research, or come visit my poster at the World Congress of Soil Science. I'll be there in person. Feel free to also email me. My email is cbrsmith at ucdavis.edu. Thank you very much for attending my poster. I'd like to also thank all the students and staff that contributed to this research. Have a great conference, and I look forward to seeing everyone.